Everybody. Since this is the last session of the day before you actually go out to the reception, I think I should do justice with time, so I don't want to take too long to begin. It's supposed to start at 2:30. We'll get started now. Um, my name is Haresh Malkani. I'm the Chief Technology Officer at CESMII. If you had been in the other session, you already know that. Uh, this session, we are trying to highlight the work that we've done within CESMII, particularly through our collaborative projects. And CESMII as an organization works that way, so we don't have internal staff that actually does the project. We work with our partners to accomplish what we need to do as an institute. So we'll go over some of the highlights of what the portfolio is, what are the specific examples, and hopefully in the next few minutes, I'll also have people who are going to be presenting 3 specific projects that are part of what we want to showcase today. So with that, because this is a CESMII event, I need to go over the antitrust statement. I'll just read it for you. As participants in this meeting, we need to be mindful of the constraints of antitrust laws. There shall be no discussions of agreements or concerted actions that may restrain competition. This prohibition includes the exchange of information concerning individual prices or any other competitive aspect of an individual company's operation. Each participant is obligated to speak up immediately for the purpose of preventing any discussion falling outside these bounds. So. Okay, I've done my duty there. So first of all, I mean, none of the work that goes on in the Institute happens without the right people in the right place. So I want to acknowledge a few folks here as we are walking through the presentation. Like I said before, I think a lot of work that we do happens through our ecosystem. So I want to thank all the project teams that have been part of this journey. A lot of the teams were made up of academia, industry, technology partners, and such. So everybody who contributed to that, you want to acknowledge them. I have my PMO team here. I think 2 members are here, Miguel and John, if you want to just raise your hand. They've been behind the scenes, working through some of these teams to complete the work that they signed up to do. If you were here in the morning for the platform technology session, the platform team, Olivia, David, Prakashan, and Jonathan are also part of this entire body of work that we're going to highlight today. And then because the work that is done through the partners involves setting up contracts with the partners, there's a whole team behind the scenes from UCLA that works around the finance and contracts and purchasing side of things. So just want to acknowledge that team right off the bat. So what we'll do today is, I mean, the purpose of this session is to take our body of work in the last 6 years or so and how we've implemented smart manufacturing solutions in different industry verticals. And how these projects have actually resulted in some measurable impact for the industry, small, medium, large. And you'll see a cross-section of projects, cross-section of industry verticals that we've been working on. And then, of course, there's some learnings as a result of that, and we'll talk about that as well. So what we'll do is, I'll first give you an introduction of what CESMII is and how we run projects and what are the building blocks that we are after, what our roadmap looks like, etc. And then at a high level, just give you a sense of what our entire portfolio looks like. So we have about 60 projects that we've done, and the makeup of those projects and how they cross-cut through multiple segments. And then I have 3 specific teams that will be talking about their projects. So let's make sure that they're there. Sudhi Bangalore is here. No, Rob. I think I saw Rob Rob from ThinkIQ? No? You been? Oh, you're here. Okay. Well, I think they'll show up, and if they will continue with some other work while they're coming here. So CESMII as a manufacturing institute is a public-private organization. We have about 200 plus members now as of last month. And they are made up of manufacturers, systems integrators, machine builders, technology providers, and academia. So it's a very cross-cutting type of organization. We are a DOE-funded institute. The 200 million that you see is a combination of federal funds and what we call cost share, meaning that the member in-kind contributions are also part of that number. We were founded in 2017, and our focus is on smart manufacturing. So if you look at any smart manufacturing solution, it has multiple components. You know, you have to have sensors, you have to have the way to do analytics, visualization, you have to have something that's able to predict the behavior of the process and then tie it back into some sort of a control system, right? But the key part there is that how does information flow between these blocks? So that's the platform side of the story. So we deal with all of those building blocks. And none of that is, you know, important if it doesn't have impact. So energy and productivity are the kinds of things that we are going after in that. So one of the things that I like to show is that just to set the stage, the work of the institute is based on how we articulate what smart manufacturing is. So if you look at this particular diagram, you know, the first step that we need to take is to actually have the manufacturing process connected so that you can actually get the data in the first place, right? That's step number 0 almost. And then once you've done that, that data needs to be contextualized. So this morning, as Jonathan and team were talking about how to structure the data and make it available to all the parts of the system that need to use it for value generation, that doesn't happen without setting the context. So that's about the platform technologies that we talked about in the morning. And then once you have that converted into actionable information, then you can take that and you can feed it back into your control system as is, or you can then do some analytics and then figure out, hey, I know what's going on. I know why it's going on. Now I have to start predicting when it's going to happen next. So this is all about the predictive area. So between the analytics and the predictive modeling side, you develop some insights and then make that intelligence available for your control system. So back in the day, in the 60s and the 70s, we talked about model-based control, and some of you may be familiar with that. But that's one form of this diagram, right? That doesn't happen without actually getting these other portions into the system. Now, this doesn't mean that all manufacturers need the entire ecosystem for this to work, right? If you look at the small and medium manufacturers, there's a tremendous amount of value just going from the manufacturing process to the point where you can visualize the information. And you can get huge benefits out of it. We have lots of stories to tell. We have worked with several small manufacturers who benefited a lot just in that. Then you talk about some of the larger manufacturers who want to be able to do this automated way of bringing insights and then through modeling, whether it's data-driven modeling or physics-based modeling, and then bring it back into the control so that you can, make the process work the way it should, right? So you can take pieces of this and then say, okay, this is what's applicable to me as a manufacturer. So in 2017, we developed a roadmap, and this was established for every institute. This is a requirement, and we had about 100 plus people that helped develop the roadmap. They came from academia, they came from industry, they came from government, and we developed 4 pillars. We're calling them pillars, but really they're 4 blocks here. The 2 of them on the right-hand side are technologies, so these are all enabling technologies. So if you said that, hey, for me to operate my process in a smart fashion, I need a sensor that works in very harsh environments. And that's a common problem for many industry verticals, and that becomes a problem that we solve, right? So that's one example of what an enabling technology is. It could be a predictive model as well. The second piece is around the information flow. So this is all about the platform, and you'll hear more about it tomorrow. You heard some in the morning. But how does the information move through your system so that it becomes smarter? The third piece is around education. So again, this is not just about the talent pipeline, but it's also the education and training for the workforce that's already out there in the ecosystem. And the last one is the ecosystem integration. This is where we bring together our members, solve the problems, and then have our smart manufacturing innovation centers around the country that can take the information, the technology, and then disseminate that through the regional networks. And for each of these blocks, we have swim lanes and deliverables that we attack. This doesn't mean that we've taken every one of them and solved it, right? This is a huge roadmap. It was not meant to be just for the institute. It was to also set a stage for what the nation wants to do in smart manufacturing. So that's the reason why it's important. And then as an institute, we have specific goals that we wanted to meet in the first 6 years of the institute's existence. And that was around energy, reducing energy consumption, cost and time to deploy smart manufacturing, increase the smart workforce capacity by a certain amount. So those are all, they're all tied together, the work we do and how we meet those metrics uh, for our sponsors. So we'll do this. I think if you, there should be a QR code. I think, yeah, on the back of your badge, there is a Slido um, QR code. If you can go to that and just answer the question for this session. So this session is around highlighting CESMII projects. Just give you a few seconds to do that. Yeah, I think they said I should just, yeah. Oh, okay. Okay. And if it doesn't happen, that's okay. It's not as important. I mean, the results will show. So, I mean, the question was, how familiar are you with CESMII's portfolio? Some of you may be, some of you may not be, just to get an assessment of the audience here. But, I had some homework to do, and I obviously didn't do it. May have mistyped CESMII. CESM. CESMII. Yeah, there you go. Is it a $M maybe? It's okay. We can skip it. That's okay. Yeah, no problem. Um, That's okay. We'll move on. Yeah. So I said earlier on that we had the way we do our work is through our ecosystem partners, and this is just an example of the 56 member teams or members that were part of our project teams um, from 16 different states across the nation. We have roughly 60 projects that we've completed in the last 6 years, and we've touched 15 different industry verticals. A lot of this work has been done, over time. So we've had multiple requests for proposals, and then we've had some projects that have lasted 2 years, some projects that have lasted 6 months. So it's a cross section of these types of projects that we've done. And again, I don't expect you to read the whole slide, but this is an example of the types of partners that we've been able to do. So I already stated some of the numbers here, but importantly enough that there's some other statistics here that might be important to you, that 28 of these projects were actually using things like machine learning and predictive modeling. Why is that important? Well, these days, if you talk about manufacturing, if you talk about advanced manufacturing, smart manufacturing, the conversation doesn't end until somebody raises the question, but what about AI, right? Everybody knows that. So we've been actually dabbling in those technologies already to get prepared, so that when we end up with some of the next generation AI type of technologies, that we are able to integrate that. 17 of the projects actually utilized our smart manufacturing innovation platform, which you heard about in the morning and will hear tomorrow as well. Roughly speaking, between 10 and 35% reduction in energy were demonstrated across many verticals. And then between 10 and 40% improvement in productivity was also demonstrated. And that these are just different types of projects that we've launched. And like I mentioned, some of them are short term, some of them are long term. So one thing that I like to show here is that because we had a roadmap that indicated how we were going to address some of the largest needs of manufacturers, that we had deliberately gone after projects that would demonstrate smart manufacturing in each of these quadrants, right? So if you look at this is a little out of sequence, but I'll just go ahead and do this. So if you look at the bottom left here, this is all about the projects that we did that dealt with things like sensing and data acquisition, and to some extent contextualization. These are the projects that dealt, with the development of the platform, and then some examples of projects that utilize the platform to show the strength of how data can be contextualized and used for value, right? So those are the two examples there. On the right-hand side, we have some examples of how predictive models were used, whether they were data-driven machine learning models or they were physics-based models, and how they impacted the operation. And then the bottom right is where we close the loop and we said, okay, here's what, some examples where you can actually influence how you're controlling the process. So that was about closing the loop. And then if you look at the type of industries that we impacted on those projects, these are just a cross section of examples, anywhere from, paper, steel, food, chemicals, thermal, cement, aerospace. These are some examples. So this was a small cross section of those projects. One last thing I'll say about the portfolio is that our goal is not just to look at the roadmap and then launch some of these project types and get the results and the outcomes, but it becomes exponentially more valuable if these outcomes can be converted into things that can be accessed by our members and the ecosystem, right? So we have a deliberate task of taking the outcomes, packaging them for use in the marketplace for the platform, or if it's an education project, then you're actually taking that and making it part of the knowledge base and the education and training portfolio that we have in the Institute. And that's how then the project participants and the industry and the CESMII members can benefit out of this. Now, this is not easy to do. There are many, many technologies that we work with where they are not easy to package for for this purpose. In other cases, it's easier to package for those purposes. So with that, I have three. So I think the first one we have Sudhi, if you're here. Okay? So you can cover his and yours. Oh, okay. All right. So we have Rob Shantala, who's going to talk about two of those projects. Yeah. Okay.
You just realized do I need a microphone? Thanks, sir. Hello, everybody. So this was really interesting. Full Bore, which is Sudhi's company. He'll be there this evening if you haven't met him already. Oh, thank you. So Sudhi's background, he was at Stanley Black & Decker and was leading digitization efforts there for their manufacturing. And he took some of the capabilities and things that they learned that kind of worked well, and he's turned it into some applications that can really help. So this particular project was done in collaboration with CCAT, I think, as well, up in Connecticut. And the intent was to come down and bring a very simple application to the factory floor for manual assembly. And it was with PTA Plastics, so they're a plastic injection molding manufacturer. They have two factories, one in Connecticut, one in Colorado, and this is at the Connecticut facility. And this first project was focused on a manual assembly line. If you were in my session this morning, I showed a little overview of the line. And the architecture is kind of interesting. So Win the Hour is the name of the application from Full Bore, and that runs in an Azure container with their app. And it talks to the SMIP, the Smart Manufacturing Interoperability Platform. And then in this case, the data that was driving the analytics was based on a camera system. But it kind of isolates, it doesn't care what it's based on per se. So for example, we've got it running in a lab up at RPI in one of the Smart Manufacturing Innovation Centers where the data source is a CNC machine, right? So it kind of abstracts the, how am I counting parts? In other words, where would I get the source of output, right? And then the application is very simple. It presents a nice, easy to understand interface to the operators who are doing the work, and it lets them know how they're doing by hour against targets. Seems kind of simple. I don't know if I can play videos, but if you go in CESMII's LinkedIn channel, I think they posted the video today, and there was a great video done with PTA Plastics and CCAT and CESMII that tells about the story. And then on Full Bore's website, there's a great testimonial from the customer. They doubled output just by giving feedback to the work, right? It's just kind of so simple. And the customer didn't have to get any new equipment. Again, this was a manual assembly line. You know, no real training for the users other than saying, hey, keep track of this. It's going to let you know how you're doing. It also gave them the ability to kind of raise their hand and say they've got issues. And they've done it in a way that he can now, you know, repeat this at other manufacturing sites in an incredibly repeatable fashion in terms of how it integrates with the SMIP. So great solution with a big focus on kind of small and medium manufacturers as kind of the primary target who have low to no skill on doing some of this stuff but need help adopting some of these things. So very, very simple adoption for the customer due to the low complexity. Helpful? Yeah, so the primary thing was how do we get this app built, connected to the platform with profiles, and then kind of not Full Bore's problem was, well, where does the data come from to get into the platform? So in the ecosystem, OnTime Edge is one of the partners that has a device that can connect to CNC mills easily. We do vision systems if you want to use that as a data source. NCD has sensors, right? So the CESMII ecosystem has a variety of partners who are creating data acquisition apps, if you will, right? Hardware and infrastructure sensors. That gets into the platform. Win the Hour is very focused on looking at the information for the platform and making it useful as a real-time analytic on the factory floor. So it's kind of a nice example, too, of abstracting the components and making them very reusable. I don't know if he has it in the, I don't know if it's on the store yet. I know it's getting close.
I think it is in the marketplace, right, David? Full Bore apps.
Did it get in there? Okay, yeah. So it is in the marketplace now. Yeah, and it's real simple, and you configure the shifts. It's quite cool. So, and the customer was, the manufacturer was super excited about it. It's a really, really cool project. Other questions? No? Okay, I'll stop channeling Sudhi. I don't know who's next. I'll go. So this is mine. We did this one. This was from a previous round of grants, I think. So the focus here was for CNC machining and building a profile. There's been a bunch of work going on creating profiles for CNC machining. This is with also small manufacturer, 2 projects that are focused on small and mediums as opposed to the big folks who, some of the industry specific research like on reducing the energy to make cement. That's pretty complicated. The other end of the spectrum is easy, simple to use solutions, right, for the small and mediums. So there were 2 things. The customer was looking at trying to manage their work through the floor. At South Bay Solutions, they're pretty much job shop. They do some stuff that's high runner, automated with robots for some parts for an automotive manufacturer. But most of their market, they're out in the Bay Area, California, are semiconductor equipment manufacturers, medical device manufacturers. So there's kind of lumpy demand coming through, and they do a lot of customs. And so part of the problem was they wanted to try to shift their management strategy for the floor, kind of using Scrum, if people are familiar with software development, and try to think about all these queues of things moving through the floor for CNC machining. So we used, and I used cameras for this. We had some data connected by sensors. Most of it was driving off vision, and we were trying to keep track of which mills are available to get work, so they could kind of make sure they knew when there was somewhere to send it real time. Which mills were running, operating, and how much were they producing? So little simple Pareto charts of kind of cutting, not cutting, idle, is it being loaded, unloaded, et cetera. Most of the mills was a camera watching the mill instead of having to connect to it, which made it really simple for them. Also, real-time analytics back to the factory floor, similar concept, feedback right to the folks on the floor. In this shop, like many, they'll assign an operator a set of mills for the day, 3 to 4 mills, and a pile of work orders, like, go get them. That's kind of the management style. And just left up to the devices of the operator to do well that day, basically, right? So these, in this case, the displays were up over the aisles where they were running, so everyone could glance at it and see how they were doing without having to kind of have a display on each piece of equipment. One of the bottlenecks was inspection. So we also had monitoring going on in the measurement room to keep track of where things being measured, et cetera, because that was often a really, really big gap. And the 2 things would work together to show that they were waiting for first article inspection. That workstation would stay idle till it came back. The operator might be busy on other mills, right? But they weren't cutting metal because they were waiting. And they tried to use it to then turn it into kind of more of a FIFO and have a hot lot concept that they could manage with some of the information from the ERP system. So pretty interesting project, big boost in throughput, just again with real-time feedback to the people doing the work and to management helping to better manage these queues of how the work should get fed to the different mills and to the QC room so they could kind of get stuff out and hit dates. Okay. And then we've got the profiles available in the library.
Excellent. So this is one of the projects that was one of the, I think, the feeders to what was shown this morning by Jonathan and team. So, yeah. Very good. Okay, and we have Yubin. You can come up here and.
Yeah, good afternoon, everybody. I'm Yubin Guo from Rutgers University. And this project has been supported by CESMII and for sensing for legacy machine. So basically, what I try to show, is this case. When you're machining, milling especially, a delicate structure like a turbine blade, and chatter happens a lot, okay? But currently, there's no effective method to sensing and supply the chatter in real time. So what I mean in real time, it means less than 10 milliseconds, best maybe less than 5 milliseconds. And otherwise, for example, for the high value component like a blade, and when the chatter happens, you have feed mark, the surface roughening very bad, and you have to hire people to manually polish it. So the cost is very high. So by leveraging the CESMII, the grant, and we try to use the 5G technology and to real-time sensing, learning, control the chattering phenomenon. So the one. The second objective is, and it's possible to eliminate like a spider web, manual wire, especially when you're machining part when they're rotating, and the wire actually definitely is not good. And the second thing is, if we have several machines in the shop floor, and how do we do real-time synchronization? in broad case, suppose you have many different manufacturing sites in different geometric locations. How do you, synchronize the production line? So 5G actually provides a very good way, enabling technology to do that. So in this project, we just use this mailing machine, and we try, can we just use 5G and to demonstrate how we can sensing and monitoring the chattering. So this basically objective. Actually, before the project, we spent a lot of money already. Oh, sorry. So, okay. So I only use this laser here. All right. So this is our lab here. You see, this is our manufacturing space, and we have 5G network. This is the customer-made 5G network, and each machine we have built-in sensor. And for this CNC machine, we have accelerometer here, and we retrofit the accelerometer into 5G enabled, and to communicate our 5G network. And so the stage one is, when the milling and the accelerometer really pick up the vibration signal and send to the 5G server, which is the edge server in our second floor there to cut the latency through our small node. And on the 5G server, we also have a model, which is the machine learning model, and to detect, predict the chattering phenomena. So once we, we first offline training the model, then we put on the model on the 5G edge server. And when the server when the model gets the new signal, when you do other experiments, they make a prediction. Then we just translate the prediction into control to our system. So this is our configuration here. So right now, also based on our research, and we can successfully, get the signal from 5G enabled accelerometer, and that data can feed our machine learning chat prediction model. And for the control part, and we can do control and model control. We at least we can control the rotational speed. The latency right now, is less than 20 milliseconds. And the most, latency comes from the control part. So we use the C++ to implement that control algorithm, and that definitely increases the latency a little bit. Right now, we're thinking about how do we reduce the latency due to control algorithm. So another thing we are working on is this morning you talk about, smart management profile. So the big question is how we can implement, this digital twin in the smart profile context. So I think that's the thing I'm working on right now. So that's basically my presentation. Thank you very much. Comments, questions?
Thank you.
Nope.
Yeah.
All right, thank you.
So I'll go through some other examples from our portfolio, and depending on time, we'll spend the appropriate level of detail on it. This is our another partner. This 5G is different from what he talked about. This is 5G technology. It's the name of a company, but they've been very strong partners with us along this journey. And this is a story about a small manufacturer, Wipro Manufacturing in Pennsylvania. And the idea here was that, how do you quickly get to making them capable of acquiring data and displaying it, dashboarding it, and then using that to improve their operations. So it's a standard story, right, for any small manufacturer. And in this case, they have low-cost solutions for getting data from machinery, and then they implemented not just the connectivity part, which they have an edge device that does that, but also come up with multiple applications that sit on top of that that connectivity layer. And in this case, whoops. They were able to demonstrate roughly a 10% improvement in their productivity, and then roughly about 60K a year. Again, small number, but for a small manufacturer, those are big things. And this was implemented only in a small part of the facility. They are expecting that the same type of a solution would be useful for the rest of their facility. And 5G has been working on an extended project where they're actually trying to do the same type of implementations in up to 15 new small manufacturers. So what they've learned out of this project has been now implemented for multiple small manufacturers. Some other examples here. This is again, you're transitioning from a small manufacturing to the process industry. University of Louisville worked with what was then called Argos Cement. It's now Summit Materials. And if you're familiar with the cement production process, about 60% of the energy is actually spent on the kilns. So this is where the clinker is made. That's the main step in cement production. And this is like a piece of equipment that's like a rotating kiln. It's about 120 feet. It's got about maybe 4 to 5 feet in diameter. Typically not very well instrumented. So they worked together with Argos and came up with a complete solution. You know, the diagram that I was showing where you have sensing, analytics, predictive modeling, control. They completed the whole loop and they presented the solution to Argos. They ran that solution and demonstrated it on one facility. Now Argos is actually taking that and moving over to multiple locations. But here again, it was 8% savings in energy, and for that operation, 8% is huge. And one of my PMO teams came up with the number that would power about 973 American homes. And then from a financial standpoint, it's about 1.6 million annually for them. So this is an example of a process industry, energy intensive application for smart manufacturing. Auburn University worked with one of the pulp and paper manufacturers, Rainier, to solve this problem where they didn't have a in situ measurement for measuring how much air is entrained in the pulp. And so what they did is they came back and said, okay, we could use a pseudo sensor, which is based on process signals and some machine learning algorithms to say that this is what would be measured if you actually had a measurement in place. That solution demonstrated that if you knew how to estimate the air entrainment in the pulp, they were able to demonstrate that you could actually reduce 35% of defoamer usage. So this is again more of a sustainability impact, where you're reducing the usage of materials. Savings over 13.7 thousand gallons per washers. This is washing process of the pulp. And this would be an equivalent of about 46 American homes that you would supply water to. So again, we're trying to come up with different ways where a sensor is not available, but because of the modern ways in which we can take process signals and do some machine learning on it, you can predict the entity that's of interest. This team is now working with 2 other manufacturers to take the same solution and deploy it at their facilities. This goes to the other extreme where, well, the third extreme, I guess. But this is where we are talking about a very fundamental problem in what's known as vacuum arc remelting. In that process, this is a titanium product. In order to get the purity that's required for aerospace applications, they have to melt and remelt this material 3 times. And it's very, very energy intensive. So if you cut down one step, that's like roughly 33% impact on energy. But the thing that they want to try here was that there's a method that uses ultrasonic vibrations during that remelting process. And if you prove that that works, and if you actually implement that in the actual vacuum arc processes, you'll end up saving 30% in energy there. And vacuum arc remelting is a very popular process in titanium, and that's a huge impact if you were to implement those those solutions into these facilities. So here again, Raytheon was our partner, and they've basically proven this to that step where now that solution can be taken and implemented in a industrial or demonstrated in an industrial facility. This is a project where we talked about the different industry vertical. This is the food industry. This is actually one of our first projects, and General Mills was the company, and ThinkIQ, again, our partner on the platform side of things, that they've actually implemented this solution to make things very visible for the entire manufacturing process supply chain. And the idea was to make data available, make the dashboarding visible, and then make an assessment of where the energy savings potential is. And then for the management to go back in and say, okay, now we are taking this area, these particular sectors in our manufacturing process to go after. So again, they've done this at 2 different plants, and a 2% energy savings translates into about $500,000 just for that particular facility. Here's an example of a small, medium case, and again, it's not manufacturing per se, but it's in I would consider that to be in agriculture. But these are I don't drink, so I don't know all the details. We have somebody in the room who actually does this as a hobby. You can ask him those questions. But hop drying is, again, a very, very old process. There's not a whole bunch of technology that goes into it. What the hop dryers typically do is that they have these curves that are developed that, for this much of a hop layer in your furnace, you just set it at this particular temperature, run it for X number of hours, and you'll be ready. It's based on some past experience, past data, right? But it's never optimized. So this team went in and they used simple sensors, right? Thermocouples implemented in key locations. They used some machine learning algorithms. They came up with a predictive model, and they said that here's how you can optimize the drying process and cut down X number of hours from the drying process, right? So again, you're impacting operations in terms of timing. You're also impacting the energy consumption in the hopping process. I think they worked with 5 different hop dryers in the Pacific Northwest. And here's an example of how they were able to save about 10% in energy. So, and this is a picture of one particular farm. So, David here in the back is an expert on brewing, so you can ask him all kinds of questions about this. This is another industry sector where we looked at the pharmaceutical production and utilizing some of the smart technologies, both in terms of measurements, or in situ measurements, as well as some advanced techniques through machine learning and predictive modeling. It's an area where this is regulated, right? This is a very regulated industry, so we have to be careful about how these solutions can be implemented without disrupting the normal process of regulations and certifications and so on. So they've been able to demonstrate some smart technologies in here to change the throughput of a new process in the pharmaceutical production. And then in this case, of course, the tools they demonstrated a 50% cost reduction in that new process. Now this was done at a lab scale. So again, I'm giving you a cross section of different types of projects that we've done. In this case, it was a lab scale project. There was an industry partner, and the next step is now to take it over to the next TRL so that it can be demonstrated at a real industrial facility. Going over to the workforce development side, just one example, Conrad does a fantastic job of highlighting some of the work that's going on in workforce education. But in this case, this was also one of our very first projects. MIT and Penn State had worked on developing a bench scale plastic wire extrusion device that was used specifically to develop some software that can be integrated into their curriculum for teaching students. So this is a 4-year program that they had. They brought this device up. They asked the students to work on this device. They went through the sensing part. They went through the predictive modeling part. They developed the software that goes along with that device, connect it to our platform, the whole bit, and then use that entire package to actually come up with an education curriculum that is now have been used for about 4 semesters at Penn State. So this is a joint effort between Penn State and MIT to create this. Penn State was responsible for this. CESMII team, of course, was partnering with them. And then these educational modules now become certified, CESMII certified modules that Penn State is able to use semester after semester. This is actually a great story. A small manufacturer in upstate New York. They make nutrition bars. And what they were finding is, and this is actually, I love this picture here. This is what they don't want, right? and if I remember correctly, don't quote me on this, I think it was roughly about 30% of their product was showing that behavior. So that's not good for a small manufacturer. Again, a very simple technique here. All they had to do was just make them understand that if they were monitoring their process, if they were installing temperature sensors in the right place, they could actually figure out what's going on in the cooling tunnel. The cooling tunnel is the one major step in the process here. So if you see this picture right here, that's the cooling tunnel. And just instrumenting it, right, with temperature and humidity sensors, providing a simple dashboard with a MATLAB-based predictive model to make some decisions, and then integrate that with our platform. And they were able to completely eliminate the downtime, which is the big deal for them. They changed the operating set points of the cooling tunnel, increased the productivity by 6%. And this compressor was cycling. They have a compressor in the cooling tunnel that was cycling like crazy. And they couldn't understand why. And it was just trying to keep up the temperature, but the temperature was being measured in the wrong spot. Right? So it's one of those things. You have to change the thinking, and you have to make them aware of just simple things like, if you position them in the right location and control it off of that, it makes a lot more sense. So again, a great story here. I'm going to maybe just give you a couple of examples, and I want to actually open it up to questions thereafter. I don't want to keep talking here. This is the steel story. So we had a great set of partners here that went after several aspects of the steel making process. So if you're familiar with steel making, a continuous casting process in steel, this is used by the majority of the manufacturers to make steel slabs. One problem was to actually detect exactly where the solidification occurs in this stream. So here's the molten metal. It comes out as a slab at the other end. But if you are able to detect where exactly the metal changes from liquid to solid, you can actually control the quality of that slab very easily, right? So the problem here was that how do you install sensors in that kind of an environment? So Missouri Science and Technology came up with a 3D sensor that could be mounted on one of these segments, and an optical strain sensing device that worked in that environment. So that would be able to give them the data necessary to figure out where this was happening. And then Purdue created a continuous caster digital twin, so they can tie that up and actually provide a tool to their engineers on the floor that could use this knowledge for maintenance and other cases. So again, this is huge. Again, if you do this right and have it implemented, it's got a huge potential for the steel industry as a smart manufacturing solution. So I'll skip over the next few that you'll have access to some of these things through our website as well. But my PMO team isn't here, but I asked them to put together some things that we learned from this whole experience of running 60 different projects, cross-cutting 15 different verticals and small, medium, large manufacturers. And as an institute, we have to be aware that we are bound by certain processes. We are a public-private institute. We have to be aware of the process that we need to follow as a taxpayer-funded entity. We found that the process timeline from proposal to kickoff needs to be streamlined. So a lot of our small partners, they found it very, very difficult to follow that, and we have to be better at doing this. So from the time that you make a proposal to us and to the time that we kick off, we have to shrink that cycle significantly. That was one of our learnings. Small manufacturers need help in proposal writing and contracting. So large companies typically have teams like within their organizations that can deal with government funding and contracting, and they can, they have internal capacity to do that. Small manufacturers don't. So one of the ideas was that could small manufacturers work with some of the larger manufacturers as a team and then solve similar problems, but then have the large manufacturer take on the responsibility of actually governing the process, which may work. If not, then we have to, we also have to be aware of what we can do as an institute. The clarity on why, what, how, who needs to be reinforced. I mean, this is a evolving ecosystem. Sometimes it's not clear at the beginning of the project as to how this is going to work out. As we move through the project, things become more clearer. We have to be adaptable to that. Expectations before the projects are kicked off. Again, because many of these projects still fall into the early TRLs, so they become, by nature, they're more R&D. But the expectations have to be clear as to what is it that we want at the end of the project. And sometimes making that clear right at the beginning and then sort of monitoring that process through the end is helpful. And we've been trying to do that lately with some of the later projects. And then lastly, and probably one of the most important things is that once we have a project completed, the outcomes need to be packaged and made available to our members and our ecosystems as they need it. And that becomes, it has some challenges. So for example, some of the teams that have academia involved, the process of getting their completed IP and then transforming that into something that can be put up in the marketplace or putting, made available outside of the university environment or the institute environment becomes a challenge as well. And so we have to work with them to make that happen. In some cases, the projects like, the ones that Rob was describing earlier on, those are a natural fit because the output of that is either an app or a profile. That becomes easy to put in the marketplace, and it's not as complicated. But in other cases, like the sensor that I showed you, the 3D sensor from Missouri, we asked them, do you want to commercialize this through CESMII? I said, well, we don't know how. So then we have to do the hand-holding as an institute for them to, take them across the finish line. So some learnings like that as an institute. I wanted to just make sure that we had time to articulate that. Yeah, so the question is, how do the project teams get put together? So we typically have, I talked about the roadmap before. So within the roadmap, we identify some areas that we want to go after every year. And we say, based on those areas of interest, we launch an RFP, a request for proposal. And then we announce it, different teams get together.